Welcome. In this screencast, we're going to take a look at some transformations in the Euclidean plane, and we're going to try to decide, given a transformation, what kind of transformation it is. Given the image and the pre-image, what transformation accomplished the work. So for example, here is triangle ABC and triangle DEF. One is the image of the other after a transformation. Pause for a moment. What kind is it and how do we know? So we definitely would say that triangle ABC is congruent to triangle DEF, the points in that order, which means that A maps onto D, B maps onto E, C maps onto F. What's the transformation that does that? Well, we suspect that it is a reflection in a line. So where's the line? How do we find the line? Well, we would take the perpendicular bisector of the segment connecting A and D. Here's the perpendicular bisector of the segment connecting A and D, and we would say that that is the reflection line. And then you might say, well, wait a minute, why wouldn't we take the segment connecting B and E and find its, oh, that's probably why. Why don't we take the segment connecting C and F and find it? Well, that's the, okay, well, why does it do that? Why do things work that way? Well, think about all the points on a reflection line. All the points on a reflection line are equidistant between the pre-image and the image, right? All the points on the reflection line have to be just as far away from the image points as they are from the pre-image points. Well, that goes for all of the points on the perpendicular bisector of segment AD. All of the points on the perpendicular bisector of AD are equidistant from A and D, which means they are equidistant from B and E, which means they are equidistant from C and F. So when we look for the reflection line, we can do that by taking one point and its image and then finding the perpendicular bisector of the segment with those as endpoints. So how about a rotation? And we know this is a rotation. This cannot be a reflection because if we say that triangle ABC is congruent to triangle DEF in that order, ABC has a clockwise orientation, DEF has a clockwise orientation. Under a reflection, orientation changes. ABC is clockwise, DEF is counterclockwise. But under a rotation, ABC is clockwise, DEF is also clockwise. Orientation is preserved under rotations. So also under translations, but this is definitely not a translation. Why? Because we can take the segment connecting A and D, and here's the perpendicular bisector of that segment. Well, that's not helpful unless we take BE and find, like so, its perpendicular bisector, and then we think, is that the center of rotation? And the answer is yes. How do we know? The center of rotation has to be equidistant from a pre-image point and its corresponding image point. And the center of rotation is the only point that is equidistant from all of the image points and their pre-image points. So this must be the center of rotation. This is definitely a rotation. And we know how big the angle is. The angle is this big. Whatever that angle is, it's that big. And we could do that for C to F or B to E. Those angles are congruent because rotation is by one angle, and that occurs, that is true for each of the pre-image points. So how do I know that this is a translation? Well, because the other two weren't translation, right? So this has got to be by the fundamental law of classroom examples. The segment from A to D, the segment from B to E, the segment from C to F, they're all congruent. And you draw the perpendicular bisectors and they don't cross. And if they don't cross, then we can't do anything with that, right? If the perpendicular bisectors don't cross, there's no center of rotation, and that would make sense because these three vectors are all pointing in the same direction, so they're all parallel, so the perpendicular lines won't intersect. That's how geometry works. So we can know, given a pre-image and an image, we can know if we're dealing with a reflection or a rotation or a translation. Glide reflection will be easy because we won't be able to do this trick, right? We won't be able to do this trick with a glide reflection because there's a translation involved, but the orientation will switch. So glide reflection is the leftover, and there are good reasons for that. All right, that's our screencast. Coming up next, linear algebra.